All right, ladies and gentlemen, this is a new presentation I've put together on the Bloodhound. It is designed to address the Series 5 Bloodhound, rather specifically, also known as the Enhanced Bloodhound. We had a Series 4 presentation. It was a little dated, so we replaced it with this. And it also addresses some of the stickier points in there that seem to be hanging some folks up that are used to the older Bloodhounds, as well as some of the common questions that we have seen. So without further ado, we'll just click in here and start talking about it. So we're going to talk about Series 5 today. First thing I want to cover is some of the features and benefits of this unit, because a lot of people don't know they all exist. So we're going to cover them here real quickly. As we know, it's a real-time photogas infrared hydrocarbon system, very, very quick to respond, etc. It also uses real-time separate sensors for O2, CO2, and H2S. As we are probably aware at this point, the standard Bloodhound, and this slide is about the standard Bloodhound. It reads C1 through C4, and it has an extrapolated real-time model. So it uses a percentage-based, if you will, model to run back against the total gas number and give you an extrapolated real-time of the breakout. It has quadruple data redundancy into its own internal memory system, to the flash drive that's plugged into the surface, to the internet, and from there anywhere else that you've got. So technically it could be more than quadruple, but it's at least quadruple. The internet capable monitoring, as we know, we can do a lot of remote stuff. We've even had short courses on specifics around what you can do, but there's an awful lot of power over that Bloodhound remotely, not just in changing it, but certainly in looking at the data and evaluating it. We are fully WITS compatible. WITS uses a standard format that was set forth by the ANSI Standards Board. We follow that format, so we work with any WITS device that also follows that format, which includes almost all of them. I have not yet run into one that doesn't. We have a gas analysis software suite. Keep in mind that's not a full strip logger. That is a gas-specific analysis suite. It goes deeper into gas analysis than a strip log system would, but it also does not include things like your lithology, etc. Website is included separately with each Bloodhound. When you get a Bloodhound, just call support or get a hold of us on email and ask for a username and password with your Bloodhound number, and let us know who you are so that we can write it down in our logs and we can set you up. We have remote monitoring and alarming capability. That includes, of course, the PC that's plugged into the Bloodhound next to it can make all sorts of noises depending on what's happening, but we also have it through the website as well. So you can go to that same website I was just mentioning, set up your pager, whatever, and it can monitor you remotely. The power system is pretty unique. It uses a 12-volt power supply. It also has an onboard battery backup failsafe. That failsafe includes a battery now that can last up to 4 hours depending on the scenario. So it's quite a piece of equipment. So moving on. Now we're going to talk specifically about what's in the Series 5 that's not included in the Series 4. As we know, it adds pentanes, IC5 and NC5. There is an optional hot wire element that's going to be put into the Bloodhound here starting within a few weeks from now. So I put it in this presentation because it's going to have a pretty big impact quickly. You'll be able to switch back and forth between the two types of sensors, either an infrared sensor or a true hot wire filament-based sensor. As we know, it has a network sensor array. That means that the sensors work together to come up with the sample. I'll explain more about that later when we get into the scaling of the unit. We have speaking of scaling, that's the next thing. There are two different scales. There's an enhanced scale and a backward compatible standard scale or classic scale. It has a new high reliability pump system. I man the support desk as well. We have literally seen one legitimate pump failure in the field since January. That one may even have been a result of some abuse, we're not sure. But the reality is these pumps are nearly indestructible. We get a lot of people calling about saying the pumps are goofy, and the reality is it's something else that you're looking at. It's just that the air conditions look similar on the face of the Bloodhound. So be sure to troubleshoot a little deeper. Don't just assume it's a pump. It's probably not anymore, not on a Series 5. We have an integrated two-phase flood protection system. As you know, flooding the instruments is a bad scenario. So when the water makes it up to the system, there's a 1 micron heavy-duty medical filter on the inside has to be dragged on pretty hard. Once that's dragged on hard enough, if there's enough seepage through it to get some water in the line, there's actually a specialized water sensor wrapped around the tube that looks for that water contaminant. As soon as it sees it, it shuts the unit down. And you have the opportunity to blow the thing back. You can blow right through the filter to clean it out, put it back together again, and it lights up just like normal. It has an integrated 3G, 4G cellular modem, and there are two options on which carrier you can use. We've always used AT&T as the classic carrier, but we also know that Verizon covers areas that AT&T doesn't, so that is now an option. So when you call an order, be sure to know what you're asking for. It has a built-in Wi-Fi system, so if you're using the 3G or 4G system, then the option for your logger to use the Wi-Fi to do daily reports, emails, some basics is there. You don't have to pay the hijack rig site type of things. The one caution I would say there is use it for work. Do not use it for things like streaming or massive data movement. There is a certain amount of data that's bought for the Bloodhound with a little bit of extra that allows you guys to do work. But beyond that, you can run into overage charges that can be very difficult. So be aware of that. Just kind of stick to work, email, those kinds of things. A little bit of remote control. There's a proactive maintenance cycle. Basically, the Bloodhound now has an hours meter on it. And when it runs that hours meter out of 4,000 operable hours, that means actually running. Once it gets there, you're going to get a warning that says, hey, it's time to send me back to the shop because I need to get a bunch of updates, repairs, and or just regular maintenance. They do that because the sensor arrays and a few other things in that, they have a certain amount of time before they need to have a checkpoint performed on them to make sure they're still performing up to par, or if they need to be replaced, et cetera. They have a multifaceted process at the shop where they do that. So that's why they want to enact that proactive management cycle. You've got 1,000 hours before you have to send it in. So it's plenty of time to order a new Bloodhound, get it on site, switch them out, and then send the other one back. And it has a radio frequency shielding mechanism in it that's, I call it multifaceted because it's not really wrapping it with tinfoil as much as it's things like reducing back pressure on pumps and noise in the electrical circuits with large capacitors and things like that. The standard Bloodhounds used to have an issue that was associated with a very jagged curve, and that was solved in this unit using these new radio frequency shielding. Okay, the absolute basics. Let's go into the Bloodhound. First of all, I'd like to talk about a feature that I think is cool. It's the dust resilience feature. And what happens is he's got a positive pressure scenario going on here so that there's a fan that pulls and a fan that pushes. The fan that pulls is on the bottom of the case. So if ever your Bloodhound is overheating or anything like that, simply lifting the right-hand side of the Bloodhound an inch or so, that'll actually allow it to breathe a lot better. You'll have a much better scenario that way. The second piece is this inlet that you see on the upper right of the screen, and there's a big dust buster filter that goes on that comes with the unit. Make sure you put that filter on, because what happens is the inlet fan actually pushes harder than the outlet fan can pull. In the process of doing so, it makes it so that even though there are gaps and holes and things like that in the Bloodhound, if dust gets near it or something, it's blown away rather than taken in, because it's it's competing with filtered air is basically what's going on. So it's a really cool feature. All right, what's in the pouch? Pouch is fastened to the underside of the lid. If you haven't ever looked at it, you probably should, because it's got some really great stuff in it. It has a placard that identifies how to connect to your Wi-Fi system, which includes the password, because it's a little bit secured there. It has a bench analysis of the last chromatograph run when it came out of the shop. This tells you that it's in good operating order. It has the full operations manual, good read, and the antennas and cords that are associated with getting the thing rigged up. So if they send you anything extra, that'll probably be on the outside or maybe even under the lid, but inside the pouch is an important spot to remember too. How do you identify a Series 5 Bloodhound? Pretty obviously. There's a sticker on the front with a 5 and 3 numbers, or on the LCD itself, there's the same thing. You see 5 and 3 numbers. I don't know if you can read that over the webinar, but it's the same concept. And that's what it looks like in real life. Talk about getting connected. And this is where it's going to get a little more complex. We're going to start with the physical connections first. So this is where you hook your wires and your filters and all that kind of stuff. I like to start on the upper right here and go down, 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 down as we go left. So it's going to seem a little counterintuitive, kind of like Egyptian, but there's a reason for it, which is that the most important thing we're going to look at first is this, which is the 1/4-inch sample inlet. This is where you plug your sample line. Next is the exhaust outlet. Also very important to plumb that properly. You always want that descending. You never want to see that thing rising anywhere, because if it gets moisture in it, it could actually plug and waver and flutter in there, and it actually causes some real weird readings to occur when there's back pressure in the HRM block. HRM is the hot wire replacement module. It's where the sensors are. It's a sensor block. So you definitely don't want any back exhaust pressure. It's a big deal. This is your chromatograph exhaust. Some people have asked, venting gas to the trailer, but the reality is you're dealing with so few microliters. It's actually, I think it's because of the filtration system. I think this is what's coming out of there is cleaner than what you're breathing on a well site. Then we have a geolograph connection. There are still a few people out there using direct geolographs. This is kind of like an old speaker connector. You just press in on the button, feed your wire in, let go, and it's connected. And when a contact is made, you will tick a foot. This is the classic RS-422 Pason WITS connector. I think they still use some of these. I think they have other options as well. But if you don't have an EDR in the trailer, you can actually connect directly to this port, and the Bloodhound will read it straight from Pason. The next one down is the 9-pin WITS EDR null modem connector. And I wrote it that way specifically. It requires a null modem cable. So when you get a modem to hook to your WITS system, if it's not provided by the WITS guys, because they all have these cables or they know what cable to use for sure, make sure it says null modem on it somewhere. And I recommend picking up 3 of these. They're notoriously made in parts of the world where they don't have the quality standards they used to. And I actually had a guy have 3 of these in a row that were bad once. So make sure you have a few extras of those. This is a 9-pin serial port. It is not a WITS connector. So don't think a serial cable connected to here is going to get you WITS. It's not. This is actually the equivalent of the next connector, which is the USB connection. That is what you use your rig site computer and connect to. You load drivers on your rig site computer before you ever put this cord in. That's pretty important because Microsoft just updated those drivers, and if you plug that in, your PC is going to go to the web and try to pull down a set of drivers that don't really work that well. So be sure that if you're going to use that, load up your drivers before you plug in there. Next, 12-volt power out. If you're using a cavitator of some sort, which is another product made by Eyeball, if you have interest in that, please get a hold of us. We'll let you know. But they have a DC, air, AC, and certified Class 2, Division 2 explosion-proof agitators, extractors. They're pretty amazing, actually. This is what you power it from. Take these 2 lines. So that's good. Then we've got 110-volt power. This is actually also how you turn on the Bloodhound and off. Just plug it in, it'll turn on. If you disconnect it, the unit will start running on battery. You can hit one of the red buttons in order to get it to shut down. This is where you connect the cellular antenna for that 3G, 4G modem. This is it's a mixed bag. On one hand, it saves your butt, but on the other hand, it's a really annoying speaker. It makes a lot of beeps and loud noises when things start to go bad. So it's important to have that working. This is the Ethernet connection. So if you're going to connect on site and use the RigNet, like for example DrillCom, then you would hook this connection into some sort of an address-giving device, like a router. So that's pretty important. On the inside of the Bloodhound, I don't have it illustrated, but on the inside there's actually a 5-port switch that's connected to the internal router to the unit. If you're using this to connect your PC, for example, instead of going through Wi-Fi, you could hardline it in here and connect to that switch. Or if you had more than one PC for whatever reason, you can actually run a line through this next port And that's what that's for. It's to run an interior line to the switch on the inside if you need to connect an additional device. Then, of course, we sort of already talked about the cooling tank fan. Again, use that dust buster filter. It's pretty important. One thing I would caution against, actually, I'm going to talk to it twice. I'm going to talk to it here as well, though. If you're using this, don't connect to DrillCom or some other rig network. And by this, I mean the cellular antenna. If you're using the cellular antenna and the cellular modem, don't connect to your on-site rig network. If you do, your Bloodhound can actually become a gateway to the internet for the entire rig network. So you want to make sure you're using one or the other, but never both. It also messes up the data online because it goes two directions anyway, so you don't want to do it. Next, let's talk about communications. So we have kind of three sections here. We got the well site itself. This is all the stuff that's actually right there with the Bloodhound. The transit layer, which is how the communication occurs and includes the internet, and I didn't draw them specifically, but the web servers that are associated with your Bloodhound are included in this layer on the internet because that's really what they are. They're part of the internet. And then any remote tools you're going to use to look at these things from afar. So first, I think you recognize what the Bloodhound is and probably what the width EDR is, and we already talked about the no modem connection between them. We also talked about the USB connection to your local computer. You can also go through the LAN. So if you want to go, if you have a router, or if you want to use the Bloodhound's router if it happens to be on, you can have those two talk to each other over the local area network. I brought these up together purposely. It re-illustrates what I was just telling you. Use either a field data network with a LAN or the Bloodhound direct cellular, but never both. You do not want that gateway situation. So it's one or the other. Of course, there's the internet. Yay, big cloud. Remote tools. Lots of different things you can use for remote, including the exact same piece of software that's used on site, the gas chart software. You can use gas chart software. You can use Eyeball Remote Website, which is the unique website for this Bloodhound. You can use a dashboard website called Multiview, or you can use a specific, I call it a dental tool, if you will, the real-time data viewer, or we call it RTDV for short. And then, of course, for your customers and or bosses and or anybody else who's just curious to watch what's going on, the website is completely platform independent. He actually wrote his own web server for this. So any mobile device that can display an image and HTML should be able to bring it up. There's iPhones, iPads, independent computing systems, whatever. Now let's talk about how to operate the thing. First of all, we got the LCD display. Yay, there it is. Bottom left are the big numbers, the whole depth and the current true real-time total gas reading. So if you're ever using a lighter to test it, that's the number you watch. I'm going to do this row by row or section by section. On the top row we have the time, the date, the case temperature, and the sensor block temperature. Next row we've got the current job ID. It's important to note that job IDs really are associated with any downhole track. So when you start a new downhole track, for whatever reason, if you reel that bit up to go to a new sidetrack, or if you have somebody in the width EDR decide that they're 1,000 feet too deep and roll the counter up 1,000 feet, that's a new job, because otherwise you wind up getting duplicate records for the same footage, and it produces a real mess on your log. So just remember, set a job when you go up hole, or when you complete a well, be prepared. Next, serial number. Again, I said there would be a 5 and 3 numbers. In this case, it's 5,000, which actually I don't think exists, but that's fine. The date, I'm sorry, we already talked about the date, but the firmware version is the last piece. In this case, it's 242. I think the current version is actually 243, but the point is, we may ask you what version of firmware your Bloodhound has, and that's where you'll look to get it. If you ever call us for support, we might ask that question. Then we have the dual display of ROP, both in feet per hour and minutes per feet. And we also have the individual sensor voltages. Then we have the extractor amperage. So if you're using that cavitator and you're connected to the DC out, the motor and the length of the wire and the thickness of the wire will have a certain amount of draw. If this exceeds, I think, 7 or 8, it winds up throwing an alarm because you're pulling way too many amps for what you're trying to drive there. There's your chromatograph column pressure is next. At sea level, it's usually 11 to 1200. As you go up in altitude, I think up here in Colorado, where we are, it goes down about a couple hundred points. So 900, 800 is actually acceptable up here. Then we have a sample vacuum and flow rate. Those are important numbers for diagnostics and watching how your bloodhound's behaving. Here's our hydrogen sulfide readout. If it's turned on, it'll show up here. By default, it is turned off, just for the record. And we have oxygen and CO2, and then the multi-field on the bottom right. This is a rotating data field. Right now it's showing RSSI, but it actually flashes a number of different values, including the condition of your internal storage and external storage systems, whether or not your modem is connected on or off. It talks about your chromatograph countdown timer. So there's an injection that's taken into the chromat once every number of minutes, and that's the countdown to when the next one is going to occur. Whether you're muted or not, what your current width status is, of course, main log mode if you're using a main log system, which is a type of a strip logger, and the IP address if you happen to be on a network. So that's a pretty important field. We'll probably ask you about that if you ever call in as well. All right, the button's on the control panel. Yay. I just got an updated email on this, so I don't know if I'm 100% right on these, but I think I'm close enough. Upper left, the start, stop, or escape key. Basically, what I mean by escape is if you look at the bottom box, if you're in a menu or something, you can hit that key and it'll just go back. It'll go back to this display, the regular display. Also, I noted that it was a shutdown key. So you pull the cord, hit that key, power down. Sometimes it's finicky in that case, so you may have to click it a few times, but it will eventually power down. Next one is the high vacuum indicator. So if your vacuum goes up, I think it's 180, that light's going to light. Sample system fault indicator, not just block sample line. So the point is, if you get that vacuum indicator, the block sample line is going to be lit, but it'll also light for pretty much any other error the Bloodhound's going to throw. So we get a lot of folks that call and say, hey, I got a block sample line, but I don't have a block sample line. The reality is it's good to look in the software and or the website and see what the error code or the error description is, because it's something. It might not be even remotely related to vacuum or block line. So it's just, we've only got so many buttons out here we can light up when we've got a problem. So he chose that one, and it makes good sense. If your chromat pressure goes too low, that's going to light up. This is a pretty green button. It has absolutely no function whatsoever. It's a placeholder for now. In the case of accessing the system menu, and if you see the white lines printed on there, it actually says menu. You hit those together, bang, and you can get into the system menu, and it does things like gives you access to change your job number, set your current depth, change register values. There's a lot of things you can do in that menu. We'll be looking at a video of that in a little while. And then there's the mute, which is tri-state. So it's mute on all the way, mute for 10 minutes, or no mute. So remember, that's a 3-clicker there. And so that's why when we looked at this field on the bottom right, one of the options was mute status. Depending on which of those 3 states you're in, it'll say something different up there. And then last but not least is the active USB flash port. The newer units, or at least some of the units, don't even have a secondary port. This is really just kind of a placeholder as well. It's a place to put a spare flash drive if you feel you need one, but it doesn't actually do anything. The upper port is the active one. Let's talk about that now for just a second. And I don't know if we saw it, but there's actually a knob on the surface of the Bloodhound. And if you give it a spin, it actually clicks into a menu scenario. And so we're going to talk about using that knob to 0 total gas units here. So here's a Bloodhound, yay. And for zeroing units, we're going to want to disconnect the line for sure, because we don't want to line onto 0 units, or you're going to get a real bad scenario. And we just give the knob a click, the LCD changes, and as you click it one at a time, it gives you different options to do it. So once you get to gas units 0, the mute key is the enter key in any menu. So once you've got it there, then you can just turn it to where you want to zero it to. I think I zeroed it to 20 in this particular example. I played around with it a little bit back and forth to get it there. And once you got it where you want it zeroed, and we always say zero it above zero a little bit, I can explain why later. Hit enter, and it'll accept it, and it'll consider that the new 0 point. So bang, there we are at 20 units-ish. This one's drifting around just a little bit, but it's good. So that's how you use the knob menu. You'll want to read up on that in the manual a little more. I'm not going to cover it in deep depth here. It's pretty well addressed there. Let's talk about that setup menu. This is the one where you hit the two buttons, the up and down arrows together. So in this case, we're going to go set the drill depth. So current drill depth is 150. Let's roll that back to 100. So we're going to access that menu. Again, there it is printed on the surface. Just hit the up and down arrow key together, and we've got a number of things. We're only going to use 3 keys to go through here, up, down, and mute. So I'm going to go down until we get to depth counter, set depth counter. Hit the mute key, which is enter, and now I can use the up and down arrow keys to actually set the depth to 100. Now I'm going to press that button 50 times. Yeah, that's painful. You can actually hold it down and it'll go quite a bit faster over time, so it's not quite as slow as you think it is. But here, that was easy enough. So now we've got 100-foot depth. And that is how the setup menu works. All right, now let's talk about how IR works, because a lot of people ask me questions about this. There's a few things to understand if you're used to a hot wire. There is no hot wire in this unit unless you get one with the hot wire pull-lister in it. I'm sorry, the hot wire filament system in it. So the IR piece of it doesn't combust anything. It doesn't burn anything. There's nothing to carbonize or saturate or get coated with contaminants, which is really nice. The other thing about IR is it's highly responsive. But how mechanically does it work? Well, imagine you're standing in a black room. There's your black room. Oh yeah, there's you. You're standing in a black room and somebody has suspended a number of helium balloons of different sizes and shapes, whatever, in that room. But you can't see them because it's dark. Well, what do? You get yourself a flashlight, don't you? Yay, now we got a flashlight. There's a bunch of balloons out there. Now the physics of what's happening is you're shining a light on those balloons. That light comes back to your eye, gets turned into an electrical signal and sent to your brain, which interprets what it is. And it says, okay, that's a big red balloon or a big green balloon. Well, how it works in the Bloodhound is the same way. Here we have a slightly torn apart hot wire replacement module or sensor block. You see 4 various sensors up in there and the block down below. Now, normally those would be together and the sample would be running through the block, but I tore these apart this way so that I could illustrate this, which is our little gas cloud. So now we've got a gas cloud in the chamber. Well, what happens? The IR sensor sends out an infrared signal. It's designed not to go to the bottom of the chamber, but rather to come short of that. It bounces off of the gas and returns to the sensor that also has a receiver. That turns it into an electrical voltage. That voltage is calibrated to mean gas, and then that's turned into the Bloodhound's mechanism for sensing gas. The other thing that I think is confusing a lot of people these days, that's pretty actually easy, but it's not spelled out that well, is the scaling. We have 2 different scaling options on these units, and the really nice thing is they're both very effective. It just kind of depends on what you're doing or used to. There's this standard versus enhanced, or classic versus enhanced scale. And let's take a look at this, for example. So we start with an empty barrel. Well, nobody wants an empty barrel in our industry, so let's fill it up with something good. 100% oil. Great. Now, if we took half that oil out and injected it with water in its place, then of course the oil would float to the top, and you'd have a mix of 50% oil and 50% water. Real easy to see because oil and water don't mix. But what happens when you got our little gas cloud in there? What's in there with it? Well, it's air. It's natural gas and air. So what's the definition of a unit? In our industry, the definition of a unit is 1/100th of 1% of a hydrocarbon gas mixed in air at sea level. It's that mixed in air piece that's really important for the understanding of the enhanced scale. Let's talk about standard mode for a second, and then I'll explain why the mixed in air part is so important. In the standard mode, you have a unit that is, it takes an equal part mix of all of the gases it's intended to read. So in the standard unit, it reads C1 through C4, but let's just say we're using standard mode on an enhanced unit, so we're reading C1 through C5, which is actually 7 parts because of the two pieces of C4 and C5. So roughly 14.3% of each of those completely displacing air, right? That's what they call 10,000 units on that machine. Now keep in mind, we talked about that IR light coming out, shining off, and going back. The reason this is so important is because a pentane molecule is significantly larger than a methane molecule, and it reflects a lot more light and therefore creates quite a bigger voltage. Now he calibrates for that, but if you don't take that into consideration when you create the scale for the unit, you'll blow it over 10,000 units. And we had competitors out there that had units that would read 15,000 units because they methane calibrated them, and next thing you know, there's these hot burning, heavies out there that are just driving the voltage through the ceiling and of course burning out their hot wires, and they're like, oh no. And so this is how we did it. So it's an interesting concept. We always had to explain things like, okay, put 100% methane in a standard calibrated unit, and it shows me 2,800 units. And the reality is, using this scale and taking into consideration the size of those heavy molecules, it makes room for them. And in the reality, 100% methane on a 7-part scale is not actually 100% saturated natural gas using that scale. Now, in the enhanced mode side, it does something new. And what it does is it takes that air cut into consideration. Remember I said that the definition included mixed in air. That's the piece that's critical here. So if you know that 50% of your air is missing, most of whatever else is there is probably your hydrocarbon. So if the sensors for the hydrocarbons are showing what they should for the range of the equation at 50%, he actually calculates this, and it's displacing 50% of the air, that thing is going to show you dead on 5,000 units. So if you put it on your bench and you put 50% air and 50% methane on it, it will show you 5,000 units. If you put 50% air and 50% pentane on it, it's going to show you 5,000 units. If you put 50% air and 50% anything that's a hydrocarbon, some mix of C1 through C5 of unknown, it's still going to show you 5,000 units. And the same goes for, 1,000, 2,000, 200, whatever. It takes the air displacement into consideration. The reason this becomes an issue is when you're taking the air cut into consideration, your rig up becomes magnified. The size of the vent on your extractor, the position of that extractor, the depth in the mud, the amount of gas that's actually bubbling out of the mud could displace all of the air. You could produce a positive pressure scenario in your extractor and show 10,000 units. So it's important to remember, if you're going to use the enhanced mode, sell it out to the customer properly, because I think most geologists would actually understand it. But it throws them for a loop when you're used to seeing 3,000 or 4,000 units in standard mode, and all of a sudden you flip to this new mode because you get a new Bloodhound that comes in this mode by default, and it's showing you 8,000, 9,000 units. It tends to throw people for a loop. It does make sense. Actually, it makes better sense than this scale in reality. Now, that said, we've had a lot of people that have had to change back because the reality is sometimes your rig ups aren't consistent, and sometimes that's not how you sell it to the customer. So changing scale modes is super easy. It's all controlled by register 9. If you set it to 1, it goes into the enhanced mode. That includes the air cut. If you set it to 0, it goes to the classic or standard mode, which uses the 7-part equal scale. Of course, this doesn't apply in Series 4. They are all classic mode. Series 4 is also the standard Bloodhound. You may have heard that. It used to be that we'd have to change register 36 as well, but the newer versions of firmware on these units actually change it for you when you change this register. So you really should only have to change register 9. You should only have to change the 1. But if you want to look at register 36, when set to 1, 36 should be 80, and when set to 0, 36 should be 30. You're welcome to check it, but it should change automatically. All right, complex topics out of the way. Now let's talk about complex software. Let's talk about the gas chart software, which is probably one of the most reasonable and useful pieces of software we have out here. It provides you your real-time gas and your time and over depth. So you can, there's two charts on the same page. I'll show you that in a minute. It's also your mechanism by which you populate your log. It can export standard LAS files, and those are also industry standards. So almost every logging software out there will pick up an LAS file and import it. Gas chart can be set to do this automatically as well. If you have an automated pickup piece of software like WellSite, for example, can do this. That works as well. It also allows local and remote monitoring. I think I mentioned that earlier. And it also allows you to calculate your lag. There is actually no lag facility on the Bloodhound, so the only way to truly calculate lag is with this piece of software. And it has numerous ways of analyzing your well and trying to figure out if there's issues with the hardware, with the well, etc. It helps quite a bit. So let's take a real look at gas chart. I'm just going to go ahead and run it straight from the app there. We're going to pull up our old demo database, but we'll actually be live connected to a different Bloodhound. And here it is. And so I was explaining that it's two charts. So on the left we have the depth-based chart, and on the right we have the time-based chart. And you can see the equal divisions here. Those are hours. I have the option on this gas chart control box, which, oops, it disappeared. If it ever does, go to the black section and right-click. It'll come right back. You can zoom in. You can zoom out. You can go up or down. There's a few tricks in here as well. So I've seen people try to go up and down with these arrows, and that's nice, but it's painful. You can also hold your control key, click and drag, and it'll drag you up or down. And then the third one is if you look at these gray numbers along the left-hand side here, those are actually all of the depths that are represented in the database. And there's a little red V. I don't know if you can see it over the webinar. But if you roll your mouse to the left far enough here, you can actually get an up and down arrow. And wherever you click, it will center that V and your display. We can go, somewhere up here towards the beginning. We can go towards the middle. It's a pretty quick way to get around in the database. The other type of look that we might want to take a look at is, let's go over here. Let's go to the real-time data section. Get used to this screen because you'll find it's a repeating theme. So this is what's actually coming from the Bloodhound to this computer right now, to this piece of software. You can tell it's live because it's updating this yellow text in the lower left. That's actually the tokenized data that's coming in, which supports all of these numbers you see above. We have a total gas of 474. Drill depth and drill depth and bit depth are different right now by about 4 feet. So they're connecting right at this moment. It also has our RLP in minutes per feet and our calculated lag depth, which is completely wrong right now because I just launched the software and it's actually connected to a different Bloodhound. So that's actually not right. It would eventually catch up, but for the purpose of this demo, we're not going to do that. We also have our C values that are down here. So we've got our methane, ethane, propane, butane, butane, pentane, etc. Pretty much everything they're looking at right now is methane. And we've got our vital statistics in this table in the middle. These will take some time to get used to if you're not already used to them. You learn the relationships between these three, but I'm going to give you the most important relationship to know right off the bat is between vacuum, flow rate in liters per hour, and your motor percentage. Okay, liters per hour tries to run at about 60 liters per hour. That is what the Bloodhound is calibrated to, but tries to do that. The vacuum is how much draw there is on your line. That'll help you with things like block sample lines, liquids that are in there. You can watch that. And then the motor percent is how hard the motor's working to maintain these two. Okay. All right. We won't worry about the rest of these right away because they're just not going to make a lot of sense to you. Some of them are obvious, like your Hobbs counter. That's your hours meter on the unit. Voltages and things, those are things that a lot of times we'll look at and support. On the right-hand side is a pretty important diagnostic window. This is your width complement. So these are the channels that are coming over from their width connection right now. So you have 108, which is your bit depth, and 110, which is your hole depth. And these are going to echo these numbers perfectly. The only other channel we technically would need to run properly would be 123, which is the #1 pump strokes per minute. We need at least 1 pump strokes per minute to determine whether or not our pumps are on or off for lagging purposes. Usually we'll see 1, 2, and 3. That's very common to come from a width system. So, if you're having problems with your pumps not turning off or something like that, that's one of the things you're going to want to check. And then everything else that comes over, a lot of these are not really particularly useful for our software, but sometimes people want to see them anyway. So the reality is half widths plus gamma is probably all you'll ever really use in our world. All right, there's another thing you can do out here, which is if you double-click, I like to do it on the time side, but you can do it on the depth side as well, and then start dragging your mouse around. You'll actually be dragging a green box. In this case, it's minutes. And those minutes are the amount of time I'm actually dragging on the chart. So if I drag here, it's just about an hour. And if you double-click again, you actually get this little menu up here. And probably, some of these are pretty straight up. You just want to mark whatever you've got. You want to say, hey, this isn't very good, or you want to change a few things that are in relation to your markers on the actual screen. But the most important one by far is the chromatograph view. So we're taking a look at the chromatograph view in this particular case. Now this thing slides right off the screen. Oh my gosh, that's pretty useless. So this is a scaler over here. So I'm going to scale that down a little bit, see if I can bring it in. That's pretty good. Sometimes you'll open them up and they'll look like this. And you're like, well, what do I do with that? And you just saw me move it. You just click and drag up or down, and you can drag the whole chart. So that's kind of important to take a look at as well. Okay, these guys are not set up, at least at this particular point. This is probably in the demo database. It was not set up with pentanes. So there aren't any pentanes showing on this particular chart. In a later chart, if we had pentanes, there'd be 2 more humps out here with 2 more marks on them. In here, each chromatograph injection has a unique ID at the bottom of this. So if we're ever talking to you on the phone, we may ask you to go to ID 395. You can go back and forth between each chromat run with the next and previous button. So here we go, hit next twice, and here we are on 395. Then we got some basic information, timestamps, things like that, what the total gas was at the time, as well as what the individual reads are in percent, as well as in number for this particular run. It's the one place in our software and hardware where you will actually see the units that are calculated based on the injection. So that's kind of an important piece of information. The rest of this stuff, your peak timing and things like that are in here as well. If you happen to be connected locally, you can actually go set your peak timing, and you can do that by clicking one of these buttons, coming over here. You notice you're dragging a line, and I'll just find a spot right near the top of that line. Pretty good. Double click, and I get the window that says peak timing set to 50 seconds. So, bingo. I didn't actually set someone's peak time here. We're not connected in a way that would do that. But oh, there's my gas chart control box is gone. Right click, here it is. We've got a few other options that are important here. You've got your kind of status bars here that say connected, whether you're connected to the unit, whether or not the width is feeding you, what your pump strokes per minute are, those kinds of things. This is a tri-state. You can actually click through this and turn things on and off if you're using a geolograph, for example. I can't do it here because they're force-feeding me pumps. But if I wasn't using a width system, I can actually turn my pumps on and off here to try to keep my lag straight. Setup is very important. Setup has a number of tabs. Alarms and audio, obvious. I'll let you figure that out. Auto ROP lag. So this is where you set up your lagging. It's a relatively simple lag engine. It depends on what is selected in the bottom right. So if you're selected on the black generate using time, then it's going to use this number, the minutes of lag per 100 feet, to calculate your lag, your bottoms up, and everything else. If you're selected on blue, then it's going to use the strokes off of those pumps to do the job. So in this particular case, it's switched to pump there because we're not using time. You want everything to be in zone 1. Just, that's the way they do wells today anyway, so I wouldn't worry too much about it. These are fairly obvious. You can calculate lag for certain depths. If you think it's off, you can redo some of it. We have the LAS and XLS file generation. This is one of the powerhouses of the software. It's where you can generate files, set them to auto-generate, etc. Typically, I tell people to stay in the LAS world instead of the XLS world. This is just complicated and uses Microsoft libraries, which put weight on your computer. If we stick to the LAS world, generally this is the common setting. You'll have it generate the LAS file. 1.1 seems to work for everybody. As far as I know, I've never seen anybody that didn't. And if you want your depth column to be lagged, so be it. Most people do. If you're going to auto-generate it, you put a value in here and tell it what file to generate. So that's if a well site or something is going to be picking it up. We also have a separate ability to choose what our C values are going to be in terms of units. We can put them in parts per million. We can put them in units, percent of total gas, or percent of total sample. It's important to note that that doesn't impact total gas. Total gas is up here on the right, where you can say gas units is in parts per million, or if not checked, it's in units. Those are your two options. Same thing with ROP. You can do feet per hour or minutes per foot. That's the two options. So if you check this, it's in feet per hour. If you don't check it, it's in minutes per foot. The delineation of the files, again, pretty much everybody uses tab. I don't know anybody else that's used anything besides tab, but you never know. And then, if you want to generate your LAS file between specific depths, you uncheck this and you put your start and end depth. But don't forget, when you cross that 16,000 mark, you're not going to be generating any new LAS records. Generally, what we do is we generate it for the whole database. That way we've got a complete replacement if we need it. So that's kind of important. Next one is charting. Lots of things to do on charting. So we can change what's on our chart by checking this, anything in this upper left area. We've got things like if we're going to chart total gas, if we're going to have the C-value curves in there. We can even take that Chromat screen we were just looking at, lay it on its side and plot it out here. It's useful for analysis in certain cases, but usually you leave it off because it's kind of messy. You can chart O2 and CO2 separately, hydrogen sulfide. You can decide whether or not you're turning your chart upside down or not. Some people like to log it from the top down. Some people log it from the bottom up. More contemporary to do it bottom up, but that doesn't matter. You can go either way. You can also show the off bottom and the pumps. And in this case, the off bottom is shown by a thick orange band, which I think you can see there. And the pumps off are shown by a cyan band, which is just inside that orange band. It looks to me like they've been off this whole time. I'm not sure what they're doing. They might be air drilling, I suppose. Possible. Anyway, so we got that going on. The next column is very important. It's the diagnostics column. And using this, you can learn some things about how temperature affects your reading, how temperature affects your chromatograph, how your sample vacuum and your flow relate to each other. And this is, by playing around with these and looking at your graphs and seeing what's happening, you can really see the characteristics of what the mechanics are doing on the well. We use this an awful lot to determine, what might be wrong with someone's data. This is what allows you to trend things and try to get some more deep analysis done. I'm not going to go into it in too great a depth. It's one of those things you've got to kind of figure out over time as you get more used to the data. The next one is the oil indicator, and this will basically just use one of these 4 calculations to, follow their particular method for determining whether or not there's oil. So it does seem, it seems to work when I run into it. It uses, if people ask, how does it work? What calculation does it use? Well, that's the calculation it uses right there. If you want to have a width item charted, you can chart one of these select width items, including gamma, which is pretty commonly charted. The rest of these aren't very commonly charted, but gamma we see charted once in a while. So you would select gamma, and then you check that, and it would actually chart the gamma. Bottom left, we can add gains to these. I have only once had someone actually want these things to be used, and it was only a few weeks ago. Somebody wanted all the C values to show twice what the total gas was in total. So we put the gain up to 2. It just multiplies the C value times whatever's in this column. Normally these are 1. If your C values don't add up, go check these. And then here's your scales. So right now we're scaled to about 7,000 units. Doesn't look like you're getting 7,000 units. So we're going to scale that to 1,500 units for the total gas. And we should see a different chart here when we go to redraw it. And there it is. That's quite a bit different looking because all of that stuff was down here. All this character wasn't quite as visible. Back to setup. Bloodhound tab. Important tab. Pretty good thing to have this tab and know what you're doing with it when you're connected over USB because you're assumed to have administrative control on USB. You can send direct commands to the Bloodhound. There's a chapter in the manual about what commands are available. You just type them in, hit send, and bang, it's done. You can shut it down, reboot it. You can do all sorts of stuff with it. You can do a few pre-canned things like setting depths, debounce timers, etc. You can refresh your data, etc. And you can choose what kind of connection you're going to make. Very important. If you're connected through that USB, or so be it an old serial cable, you'll want to use this one. If you're connected over the web remotely, or even in the trailer over a local area network, use this one. In the case of the web, it's easy enough to just go out here, type in a Bloodhound number, hit lookup IP, it'll populate this down below and make the connection, and you should see all these lights turn green. Bingo, they turn green. Then, if you're in a local area network, you might actually have something where it has like 192.168.1.12. And then that's all you have to do, and you come out of here, and it'll say, all right, I'm trying to connect to that. And it's going to say, oh, no, sorry, that's not legit because you don't have that on your scenario. That's how that works. I'm not really sure. I'm going to have to tell about that one. So we'll bring it back up one more time here. Let's see, what else we got going on? Oh, I got to go reset this thing up. Look it up. Thank you. So we talked about real-time data. Talked about the format. I wanted to cover one more thing before we leave gas chart. And I know this has taken a while, but gas chart's probably one of the primary pieces of software that we use. Is this bank of buttons on the left-hand side. You think of gas chart like a VCR. Think of the Bloodhound like your television station, where they're actually making a television show that you like. And so they're making your television show. They're recording it on a tape right there in the camera. Okay, that's the flash drive in the Bloodhound or the interior memory. That's the tape on that camera in the studio. Then the Bloodhound broadcasts information out to, say, a radio station. Okay, let's go back. I'm sorry, television station, not the studio, but the station. So they send their television show to the station. The station then rebroadcasts it. A bunch of people out there with televisions and VCRs are watching it and recording it. That's kind of what happens here. So if you've got a remotely connected Bloodhound, for example, and it is recording its information inside, but it's also broadcasting it to its web servers. So that's the TV station in this case. And then I'm connected remotely right now to a Bloodhound, and my PC and the database that's on this gas chart are they're the VCR, if you will. So the point being is this thing is just a VCR deck, and it doesn't matter whether it's plugged into the Bloodhound on site or if it's remotely done. When we talk about databases, database is a big scary word to a lot of folks. It really is nothing more than like a Word file or some other file you might save on your computer. It has no impact on the Bloodhound whatsoever. So opening databases, closing databases, starting new databases doesn't hurt anything. Don't be afraid to play around here. Your master data records on the Bloodhound are okay. Just important to know. Top button. That's how you generate your LAS file manually. So you go out here, you give it a name, LAS 12, whatever, generate it, and it'll go through the process of generating an LAS file. It'll tell you when it's done or disappear at the time, and does that. does this, and bingo, we are done. So we close that, and we should have an OS file sitting around out there. Then we've got the ability to do some exports and imports. Don't worry about those too much. We don't run into that very often. That's kind of something we do in support if you run into a lot of trouble. It's one of the ways you can get the data off the Bloodhound and bring it back into GasChart as a new database for you. So if you lose it, still got a backup. We can open an alternative database. So if you're logging remotely and you want to look at different Bloodhounds, you may, open up databases for whatever reason just to look at different units. You may even do that post facto. You may save all your databases on a repository and go and look at them some other time. You can do that as well. Starting a new database is something you want to do whenever you do one of those new wells, new sidetracks. Same reason you start a new job. So job, database, often go in tandem with one another. So we're starting a new well on a new pad. I'm just going to say, okay, new well 1. Okay, start a new database, blanks the chart, starts you fresh. As soon as you get enough data in here, everything's going to start up. It refreshes itself once every few minutes. You'll see the data start crawling up as time goes on. It's not a big deal. If your database ever gets goofy, like your chart doesn't appear or something like that, you can always hit the compact repair, and then you just close and restart GasChart. It probably works great. So that is GasChart. Always shut down GasChart gracefully. Don't let Windows Reboot do it for you. Don't turn off your PC without shutting it down. It doesn't like that. These database handles open. So you always want to hit the close and then confirm the exit, and then it shuts down gracefully. And that is GasChart. Next, I promise you this will get faster from here. The real-time data viewer. So I told you about that real-time screen we were looking at. There's actually a piece of software that can be used both as sort of a multi-console if you happen to be remote logging, like you see in the background here, or individually like a dental pick. And it's strictly internet. It does not work any other way. I need to go find a unit here that makes sense to take a look at. I should have written down the one I was just using. But let's try this one. Just for fun. If we get a connection, these things are going to light up. Yep, so that one is connected right now. And there's a button here that says more data. That's where I can get my yellow thing, my little yellow text that tells me, yeah, it's broadcasting information right now on the fly. This particular unit doesn't have width, so it says width's bad. It's probably a geolograph. If I know the customer, I think they're probably using geographs in this case. So that is strictly for looking only at this particular screen from afar. You can't use this on site. I've seen people try to hook it up on site and it doesn't work. I don't have anywhere to put my connection in. If your computer is on the internet and the Bloodhound's on the internet and nobody's firewall, that actually would work. But it'd be using about a 4,000-mile line to connect to the Bloodhound's 2 feet from your PC. But it's pretty useful. And you can get in here. The other thing it has is a two-way active. GasChart has that as well. But in here, it's just a quick access. If you want to go in and remotely admin the unit, I'm going to put this over here so you don't see any of it. You type that, you hit send, and then it goes two-way active, and you can do all sorts of things in here, like reboot Bloodhounds and stuff. This is an active unit, so I'm not going to play with it. But the point being, it's a pretty powerful tool. All right. Internet tools. Well, what do we got? We got Eyeball Inst. Pretty important. That would be the main website for the Eyeball Instruments team. It includes the shop. It includes, of course, the engineering groups and things like that. Probably the most important thing on here for on-site world is the downloads section. Remember I mentioned that you need to have drivers installed before you load up before you hook your Bloodhound to your PC with a USB cable. This top section is where those drivers are. The GasChart software we just looked at can be downloaded right there. The real-time viewer can also be downloaded here. There's a width simulator. If you have a bench, you want to do that sort of stuff, you can. For the record, the USB flash drive that's plugged into the top of the Bloodhound actually has copies of all of these software as well. By and large, the latest will always be here, though. So just so you know, that's an important site. We also have the eyeball remote site. That is the individual site for this particular unit. So I will do, you pull it up and it asks you for a serial number. You put in your serial number. I'll put in a serial number that actually makes sense. And the next thing it's going to do is go to login page. I'm going to do the same thing I did before, sorry. You type in a username and password. You call us to get that. Or email, support@bloodhoundrentals.com. That'll work too. And once you get logged in, it pops up to the main page. And voila, this section, again, here's that real-time data stuff that we've been looking at all along. It's just in a little different format, same information. If your site happened to be branded, you could have your own notes here. You could have your own logo over there. Get information, including online LAS files that can be downloaded. I have an admin level here, so we're able to do things like create and download a database file that would be compatible with gas chart. That's a very nice thing to do if your data gets messed up. Basic server information, of course, here's the chart. Same concept. Boy, I got nice shows. You can log out. Not going to do that. We can go in and edit our charting options. So this is very similar to the stuff that we were just looking at inside of gas chart. This will control how the chart in this particular website looks. So we can set our scales and our colors. We actually have quite a bit of power over here. Occasionally packets will get missed and there will be a jagged curve in the RLP world, maybe even in the time world. You can actually auto-fill missing packets and it'll smooth over those so that it looks prettier for your customer and generates better looking LAS files remotely. Obviously your source of record is the Bloodhound and the PC that's on site in that case. If you have a weak connection, that's probably what you're going to want to do. So we do that, make any changes you want, hit save, you'll go back to the main page. It takes a little while to do this because it's actually going through and regenerating all of the chart bitmaps when you do that. So if your bitmaps ever get messed up, that's actually a way you can go in and kind of tweak them. So just so you know. There's an automated alert section. So I'm going to just close that. Got somebody's information in it, don't really want to share that. But the concept is you can go in here and you can set up some alerts for a few different cases, such as the unit's offline, they've resumed drilling, a few other things, and you can put your pager number, your cell phone number, and your email address or something like that. You could put those in there and tell it what to alert you on, and maybe you guys are tripping and you want to know when they're drilling again, so you tell them, okay, page me when that thing starts moving. And you can do that. That's kind of nice. If you're an admin, you can get into the passwords and you can set up people to be viewers, you can set up people to be log levels, you can set up people to be manager levels, etc. That's kind of useful as well. And the admin level is what we give you when you get a new Bloodhound, you ask us. And our process is to go in here and clear out everything. We clear out all the branding, we clear out all the existing data, we clear out the LAS files, the whole deal, and all the passwords as well. So when you go in, you're going to have a fairly virgin site with no additional information or stuff like that. It's just going to be yours. So that's kind of where we go with that. And that is Eyeball Remote. We also have multi-view. Multi-view is kind of neat. Multi-view doesn't actually require passwords because what it is just a dashboard. So maybe you're watching a few different units. So we're going to watch, I'm just going to put some in here. We're going to call it Bloodhound 1. Or just call it Bloodhound. We'll do that. And I'm not going to put any notes on that one. And you add it, and it starts to create a list. See the list down here? So, and then we've got 51 and 27. We're going to call that HP200-8, whatever page, just for fun. Call it that, and let's go add a few more here. 57, 86. Super. I don't know. Okay, so we got a few out there we can look at. You can maintain this list just by selecting, deleting, etc. But when you're done, you can go to the multi-view screen, and what it'll give you is this spreadsheet. And so what we know from this thing I just typed in is these 3 different units that I've named. 2 of them are offline, which I took guesses on those numbers, so it's not a surprise. 5127 I know is online because we've been looking at it for other things. If I hover over it, I can look at its real-time data information. And then there's just some information about its current hours meter and a few other things that are really important to look at. But from a dashboard point of view, this is pretty useful. And you can always click the number and then hit the button, and then you can go right straight to that eyeball remote. So that's kind of useful. So that's how multi-view works. Multi-view is actually a great tool. Of course, in addition to this webinar, we have other learning resources. There's the manual in the Bloodhound, which we already talked about. There's obviously some information and documentation beyond that, and some things that come with it. But we also have something that is called a knowledge base, and it's bhkb.org. It stands for Bloodhound Knowledge Base. It's really, really, it should be simple to remember. And you come to this page. It's the Support Services Knowledge Base. You can do things like searches over here on getting started. Maybe we'll find an article that's specific to getting started on the Bloodhound. And it tells you about the rig up and what kinds of tools and things you want to take to it. There's the setting depth video we actually looked at earlier. Setting a job number on the unit, et cetera, et cetera, et cetera. There's all sorts of content out here, videos and additional articles, and of course it has links to other articles of use. I generally recommend people definitely get out here, they hit the home, and mark it in their favorites. You definitely want to see that. So it's pretty important. It's a living, breathing repository of information. So we're continually updating it with firmware updates, software updates, new article content, edits to old article content, etc. It's a good thing to get on. And Google, and the reason I put Google is a lot of people forget bhkb.org. If you just go to Google and you Google something like Bloodhound lighter, not light, Bloodhound lighter, and bang, like the first 2 links that come up are how to perform a basic lighter test on the Bloodhound. Guess what? It's in the knowledge base. So if you forget how to get here, you can do things like that. And Bloodhound. I don't know if this one shows up yet or not. This is a fairly new one. As the eyeball one. Oh, all the firmwares are out here. Here's some of the images. A lot of the Bloodhound stuff is just going to really point you to our world. I have nothing to do with that image in there. Okay. That said, Google's pretty useful for finding us if you can't find us one of the other ways. And with that said, I am going to. Are there any questions at this point? Anybody? Hello?
I'm good, actually.
You're good, Steve? Okay.
Yeah, appreciate it. Thanks.
All right. That sounds good to me. Anybody else? Ro? No, Ro's not there. Okay. I think we're good. All right. Because that said, we will conclude it.